started. Welcome everyone to this session about accelerating platform engineering adoption with Canoe, a project that we're going to be talking about. Before starting, once more, let me know if you have any issue hearing what I say or seeing my screen. You can just let me know in the in the chat. I'm going to be watching it. So let's get this started. Again, today we're going to be talking about Canoe. Let me go forward. First of all, you might be wondering, who's this guy? So I am Miguel Fontanilla, currently the platform engineering lead of Sennder, which is a digital logistics company, German company that spread about Europe. I'll let you know a little bit more about it later. I'm also part of the AWS Community Builder program in the containers area. I've been with them for the last 4 years, certified professional architect from AWS, and also certified in Kubernetes. You have there my GitHub handle if you're interested, and my blog where you can see other talks and basically articles about the cloud, Kubernetes, and platform engineering. Enough about me. Let's see what we're gonna be talking about today. So we're gonna follow this flight plan, to say so. We're gonna start with how to implement platform engineering based on our own experience at Sennder. What went well, what went not so well. Then we're going to talk about Canoe, this tool. We are... Sorry? Yeah, okay, all good. So yeah, we're going to be then talking about Canoe. Then we're going to jump into a demo where you can deploy the platform on your computers if you're interested on. I'll also share the instructions so that you can do it from a repo. And then we're going to go over some conclusions. The idea is to make it, enjoyable for everyone so that you can also test it on your computer. So I'm going to share this later, but just for you to know, what will you need? Basically, it's instructions repository I'll share in our channel. Linux host. I think somehow my video got frozen. Not sure if you can still see me. Do we have PlatformCon support here? I see my video is frozen. I just hope, yeah, but you can hear me, right? Not sure why. Let me block my video. Yeah, and unblock it again. Yeah, should be working again. So what are we gonna be doing today? You're gonna need an instructions repo that I'll share in a second. And an OS or Linux host, command line tools, a container runtime, kubectl CLI, and then optional a GitHub account and AWS account. So I'm gonna share the instructions repo first, so that we can have it for all of you. I'm gonna share it in the chat. So give me a second. Here we are. Where's the chat? Perfect. So again, if you need to install some of these things, you will have time for the presentation. So yeah, first we're gonna start with a little bit more of a theoretical part, and our lessons learned, and then we'll go to the practical part. Regarding questions, feel free to add any questions in the chat, and we'll also have dedicated time at the end of the presentation for other questions. I'll be checking the chat in between. So let's get started with the idea of implementing platform engineering, and this is kind of the hard way how we did it. So obviously, you're here because you already know about platform engineering. There might be different levels of understanding. So I'm not going to go to the basics or explaining what platform engineering is about. I'm going to directly go about our use case. So first of all, about the company. As I mentioned before, I work for a digital freight forwarder, Sennder, which operates in Europe. It's a relatively young company, and it was born in 2015. So in 2020, we started a hypergrowth phase. So we started to grow quite a lot. I joined them around that time. And from 2020 to 2023, the company went from 300-ish employees to more than 1,000. We got several investment rounds. We expanded our offices to different countries in Europe. And the overall number of engineering or engineering people grew from 20-something to more than 160. That came with a lot of needs. Basically, we needed to grow exponentially, and as we were having more developers and they needed to be able to deploy services and iterate fast. So iterate fast is one of the things we needed. We needed less overheads for developers so that they could bring products to market quickly. And we needed multiple environments because we were coming from a monolithic, let's say, setup that just wasn't kind of MVP that validated our business product or our business use case. So back in 2020, we decided to implement a platform engineering approach where we created a platform, central platform team that would create, consumable products for our developers that they could use in a, plug and play manner to deploy their services. So why did we decide to go with a platform engineering approach? And most importantly, why did we decide to create our own internal development platform? Well, because there are a lot of associated benefits. I'm going to go quickly over them because, again, you probably are here because you know what this is about. But yeah, we can abstract complexity for developers and embed best practices in the products we give them. We can get consistency and standardization spread across the organization through these products we give them, speed up development as they don't need to know all the nitty-gritties and the low-level details in the cloud, enhance scalability because these products can be replicated, and all in all improve developer experience. And happy developers, if you give them coffee, they get you better code. So one more concept that I want to highlight here. One of the benefits of this approach is that all participants will benefit from the platform because the platform is going to grow alongside your product. So sometimes a team might request a new feature, and if you implement this feature and make it available as a product, the rest of teams can also benefit from this one. So just interesting to take that into account. And finally, to close this part, this is a quote from Gregor Hope, real genius, and he knows quite a lot about strategies. I strongly recommend this book if you are into the platform engineering world, platform strategies. And he's saying, if your users haven't built something that surprised you, you probably didn't build a platform. And that's true. You would be surprised by how many synergies you get when you create a platform and developers use your components and your products in a ways you did not anticipate. And this is going to enrich your overall offering. So yeah, with that in mind, we were talking about I'm reading in the chat. I know that those are matching names, right? IDP. In this case, it's internal developer platform. Yeah. An internal developer platform needs multiple things. If you're going to design an internal developer platform from scratch, you will have to answer these questions. You're going to need something as a developer portal where developers can interface with the overall platform, run self-service to provision their products. Is a single pane of glass for them to observe and track stuff, where the documentation, APIs, and all the things are placed. Also, you're going to need a code and artifact repository, a CI/CD set of automation, secret management to safely distribute your secrets and sensitive data, infrastructure provisioning tools, deployment tools to deploy your applications, an actual compute platform where your applications are going to be running, observability for your overall platform and your services, and identity and access management. This is something you're going to need if you're going to design a platform from scratch. And to be honest, 5 years ago, we did not have this. Actually, these points are coming from Canoe documentation and their white paper. So it's not easy to decide on what to use, and it's not easy even to know that you need all these points. So this is already something I wish we had 5 years ago. But anyway, how did we approach this? So in our case, we decided to let's say, to address these questions. this way. So for the developer portal, we decided to use Backstage, which is an open source, community-driven developer portal, really extensible by Spotify. For code and artifacts repository, GitLab and ECR on AWS, CI/CD, we're using GitLab CI. Secrets management, SSM, secrets manager with external secrets, which is another open source product. Infrastructure provisioning, Terraform. Deployment tools, Terraform and Helm, because we use Kubernetes. The compute platform is Terraform. It's AWS, where we deploy Lambdas and EKS containers. For observability, we use Datadog, and for IAM, we have Okta. So this is a technology stack we chose. And the reality is we did not get all of this right on the first try. You will see in our platform, but just for you to know, we reached this conclusion that we needed these tools over an iterative process, because maturity is not reached on day one. This is something just to keep in mind. So this is how our platform looks like. I hope the size is fine. You can see here the architectural diagram is a high-level one, but you can get a sense of it. So on the top, we have our user, which is a developer that is going to interact mainly with the developer portal in Backstage, and also with GitLab and Datadog. These are the main applications our developers interact with. And all the access here is controlled and orchestrated by Okta. Also, our developer portal, as you will see, is connected to GitLab and to Datadog by means of different plugins and integrations to fetch and cross-correlate data and show it to developers. Then, since we use GitLab CI, and we provide templates, you will see in a second, to do scaffolding of new products. When a developer creates a new project through Backstage, this is going to come in with the scaffolding, which contains CI/CD templates. So this is going to automatically run the pipelines where Terraform will be used to create AWS resources, and Helm, in this case, will be also used to create things in Kubernetes world. There's a line with Flags there, but it's a really particular use case. For now, we can say we deploy with Terraform and Helm. So this is pretty much our platform. This is pretty much the architecture. Before we move forward to a small demo of the platform, if you have any questions, feel free to add them to the chat. Otherwise, I'll move forward. So this is a short video I'm going to share here. I hope the quality is right. I cannot do a real demo of the platform, obviously for security concerns, because there are sensitive data we don't want to share there. But you can pretty much see the features of the platform here. So let me go full screen. Let me know if you can see it. So here you can see our developer portal. Again, is Backstage. It's just we have flavored it a little bit. This is the main page. We have service catalog where we can see the different deployable components we have. You will see here in a second. We have different types of deployable components like front ends, back ends, micro front ends that are supported by means of our templates. So, you can use the catalog to see your services. You can search for a specific service. And then once you go to the page of your service or component, you can see its relations. This is the main page where you have a summary of everything. You see some checks on the right. I'll talk about them in a second. But yeah, you can see your, again, checks to see about compliance for your services. It is also connected to GitLab, so we can see issues, opening the repo, merge requests, latest CI/CD pipelines, dependencies, and so on. So this is one of the functionalities we have on this developer portal. But then we have all the things that we have coded on our side. This is, displaying DORA for metrics, for delivery rate and so on, documentation that is stored here. And this is about the checks we have. We use this for compliance and governance, and we can check, what services are compliant with our standards, like, using CPU efficiently, using memory efficiently, using the right versions for databases, defining health checks on your services. All of this is something we've built on our side because Backstage is really extensible, and it helps us with governance because we can also see who's not passing these requirements, who's not compliant. with our baselines. So yeah, we can see here some services that are not complying with that, sorry, with that. Another thing we have, as I mentioned before, is the capacity to bootstrap a service from this platform. So yeah, we have different templates. In this case, Kubernetes services with Python, with TypeScript, Lambdas using same idea, Python and TypeScript, front ends and stuff like that. Here, we're just gonna provision simple Lambda repo, just for you to know. This is sped up, as you will see in a second, because it takes like 1 minute. So what I'm doing is giving the component a name, then giving it some ownership, because we also want components to have ownership. Yeah, I'm just writing the description. I guess I was not inspired that day. Yeah, setting their ownership, and then for developers, we have a clicky way of defining what they want in their deployment. If they want to have a database, if they want to expose this thing through an API gateway, if anything that is controlled by means of our templates, we offer this way. If you want to run end-to-end tests, all this kind of things. So a developer can basically select what they need for their deployment. Then it's going to show you what you're going to apply or what you're going to create. And yeah, this is probably sped up like 5 or 6 times because it takes 1 minute, but it's creating the repo, bootstrapping the whole thing, etc. And now when I open the repository, you can see a full-fledged project with everything it needs. And it also has a built-in CI library. We have a unified library for the company that it's gonna take care of the CI/CD already for this thing. So this is just importing the centralized library. And as you will see, I have just created the thingy and it's already running a pipeline to deploy it. As simple as that, just with the clicky way, the clicky approach to say so. So this is pretty much the platform, what I wanted to show, and what I can show. So now I'm gonna get back to the presentation, if this thing allows me. So before moving forward, no, yeah, I just wanna iterate on one more idea here. This whole full-fledged platform was not created like this from day one. Backstage was not added on day one. In the very primitive version of the platform, we had our own tooling based on templates with a CLI for developers, to create the repo, commit it manually, etc. So it is an iterative process, and it takes quite some time to get to your, let's say, final design of a platform. It's also relatively hard to test, so I just want to, be really clear on that. It works, we love it, but it took us a lot of trial and error. Why am I saying this? Can I just skip this part? Yeah, so here are the lessons learned about this. What went well on building this platform? Scalability. So from in 2020, when the team was created, we were 4 platform engineers, if I'm not wrong, 4 to 5. Today, we keep almost the same size, 5 or 6. And that day we had 20 something developers. Now we have more than 160 engineers. So it scales well. It eases onboarding quite a lot because you have just seen how easy it is to create a new service. So it's really good for onboarding and teaching people. It also allows you to introduce standards for the company, but keep some room for experimentation. It's not, just like guardrails. People can still experience and experiment and think out of the box. And it's going to centralize useful information for your developers in one place. And also for managers, because you can see, compliance checks and so on. What was not so good on our side, it's hard to validate. It's hard to run a POC because you need a full-fledged platform to run this. You need to make difficult technology choices that you might not be aware of. This is why, we learn along the way. Back in the day, we had to develop some ad hoc integrations. Actually, the plugin you saw creating the templates was created by us. But as of today, and as you will see later, Backstage already offers templating engines. Yeah, we also had to create some in-house tooling. And as I mentioned 10 times, maturity takes long. It takes a long time, maturity of your platform and trial and error. So with that in mind, if we don't have any other questions, I'll move to Canoe. So here we are, Canoe. So Canoe is a open source project which which brings best practices to build our platform. Actually, I'm saying best practices like in between quotes because it doesn't bring best practices, but actually best tooling, to say so. So as I mentioned, it's an open source project. Canoe stands for Cloud Native Operational Excellence. And it's a framework that has been developed by industry leaders who have been creating platforms for a long time. Not sure if you know some of these guys like Cisco, Siemens, AWS, Adobe, Salesforce. So big guys building big platforms have basically come together to define standards and best tooling and practices. So it's gonna show us multiple options and best tools to build internal development platforms, and also brings reference implementations. As I said before, it's open source and it's driven by the community and the CNCF, and it allows us to deploy Kubernetes stuff and more, as we will see, not only Kubernetes, even though the backbone is thought to be deployed in Kubernetes. And it's going to help you defining your stack because it's going to provide with multiple options, like for GitOps, you might have Flux versus Argo, from infrastructure provisioning, crossplane versus not actually Terraform, OpenTofu, but same idea. So, well, and obviously the fun fact is the logo is a canoe because it sounds like a canoe. So moving forward, this is what Canoe kind of suggests as tooling. This is just proposals for the different aspects. If you remember the bullet points we said before, where you have to define a developer portal, a CI/CD tool, an infrastructure provisioning tool. So this is kind of an idea. So for example, they suggest for identity and access management Keycloak, obviously because it's open source. Yeah, give me a second. I think my camera failed again. Yeah. So same idea. They propose external secrets for managing secrets. You can imagine for continuous delivery. They mention Argo CD and Flux. So yeah, they give us reference implementations and the best possible tooling for building an internal developer platform. With this in mind, I'm going to introduce some of the concepts we're going to use in Canoe. So the first things are the packages. Packages are the base set of tools we're going to deploy for Canoe, for creating this architecture. And they have multiple flavors, multiple options, and we will see. Then we have plugins, which are integrations between the tools. You can have plugins for Terraform, for, in this case, actually OpenTofu, but Argo workflows, Apache Spark, local stack if you want to emulate a local cloud. It also provides reference implementations, local versions, and we will see, and cloud native versions, in this case, as of today, intended for EKS in AWS. And then it brings additional tools, the IDP builder to run your own IDP locally or in pipelines, and also a CLI for templating. So just, small introduction to these concepts. IDP builder, we're going to be playing with this thing soon. So the IDP builder is a CLI developed by the folks in the Canoe project, and it allows to run a local IDP in your local machine. And it also works in code spaces, so you can run it on your CI. And it's a good idea for, building a test environment for the platform engineers. If you remember before, I said that testing new functionalities in our platform might have been difficult because you need to replicate the full environment in depth, full running backstage and every integration to test. This one is simple because you run a small version of your platform and you can use it for validation, functionality testing, and so on. And it works on CI/CD as well because this thing is going to deploy a kind cluster, which is Kubernetes mini cluster running in Docker, and it can be running in code spaces as well, in GitHub code spaces. So we're going to be playing with this tool in a second. The other thing we're going to be talking about is the reference implementation. You can think about this thing about the IDP builder or the brother. It is the repo is there. We will see it later. It's a production grade, quote unquote, production grade IDP with endpoints, certificates, IAM, DNS management, and so on for EKS. So as I mentioned, it's targeted for EKS, but a smaller version that we will run is available also with IDP Builder. You can think about this thing as the first deployment of your platform in the cloud, not as a local thing that you can extend. And just a word of caution, we will not deploy this one because a new version is still under development. They're going to release it soon. So I don't want to deploy, the old version because it's costly in terms of cloud resources, and it's going to be changed soon. But we will discuss the reference implementation. If we will see it later, but the reference implementation, it's an opinionated version deployed in EKS, where they use things like Nginx Ingress, external DNS for Kubernetes, Server Manager for provisioning certificates, Argo workflows, Crossplane or Terraform /OpenTofu for provisioning infra, Argo CD for deploying applications. So this is pretty much what this reference implementation deploys into EKS. We will see it later. So before moving to the demo, the actual workshop part, because you can run this on your local machine if you want. Any questions? Anything that is not clear? Anything you want to add? Sounds that it's pretty clear. So I'm going to move ahead onto this demo part. So again, recapping, what are we going to need? There's this instruction repo. I'll share it again. Give me a second. Here, we're going to be focusing on following this approach. These instructions here. You're going to need an OS X or Linux host with a command line, bash mainly, a container runtime, Docker, Podman, OrbStack, whatever you want to have. Ideally, kubectl, and optionally GitHub account and an AWS account. If you don't have it, it's fine. I will show you how it works on my screen, and then for sure, once I finish, I'll update these instructions with screenshots of the whole process so that you can also follow if you're watching this thing after the recording is released. So what are we going to be doing in this hands-on lab? So we're going to install IDP Builder on our local setup. We're going to deploy a basic platform first, the bare minimum. Then we're going to deploy a full platform with more components. And we are actually going to deploy infrastructure in AWS using this platform, this local platform, just to test the whole integration. Finally, we have time. We can also try IDP Builder in GitHub code spaces, and just to close the whole thing, review the reference implementation. So I think I'm gonna just swap windows. Give me a second, and I'm gonna need some feedback now to see if you can see my terminal. Please let me know if my terminal is visible. I need to resize it a little bit. Okay, is the size okay for everyone? Good, perfect. Remember to open the Canoe workshop documentation I shared if you want to follow this thing. We're gonna do it slowly, so no worries. I'm gonna reinstall this thing. Okay, I know not everyone is a big friend of running random bash scripts that you get with curl. So in the documentation, there are other ways of installing this thing if you want to check them. You can download the latest package by hand, and just move it. I'm just gonna do it this way. So I'm gonna, install IDP Builder. Obviously, it requires password. So now it's installed. Can we have the presentation and recording in the end, please? I think so, but I guess the organization folks will take care of, putting together the recordings and sharing them. So I'm trying to install a dev container. Will it be painless? We shall see. Mohammed, good luck. You tell me if it works. So now we can check the version of IDP Builder. It's here, it's installed, so we can see IDP Builder. What can we do with this thing? So you can see completion, create, delete, get, blah, blah, blah. Okay, so I should have my container runtime running already. So let's verify Docker container. Actually, I don't have anything, but I might have. Yeah, it's up and running. Don't you worry. So what I'm gonna do is very, very simple. I'm gonna hit IDP Builder create. And this thing should do its magic. What's happening behind the scene is that this thing is creating a kind cluster, which again is a Kubernetes cluster embedded in Docker, in a Docker image. And on that cluster, it's going to deploy some tools, and it's going to do some other patching for us. But we can check now. Sorry, we can do Docker, not Docker container ls. We should see we have kind container running. I'm gonna clear that out. So if I try to get the things that are in my cluster, you can see now it's installing Argo CD, DT, and Ingress Nginx. So it's installing some things in the cluster, and they're gonna be made available for us in a moment. Again, this is the basic flavor of the platform. There's no backstage. There's just the bare basics. But still, it's powerful because it's already coming with a code repository and GitOps automation to deploy. So these things take some time to start. That's the only thing. But yeah, let's see. Actually, we could see the ingresses. Okay, we have an ingress for Argo CD. It's still thinking, provisioning the rest. I hope the size is fine in the terminal. Okay, still provisioning some stuff. Now we have another ingress. Okay, it's finishing, I promise. Sometimes it takes a little bit longer. I'm just gonna copy the host names to verify is it working already on my machine. Not yet. Yeah, maybe we should have some background music for this thing while we provision it. Okay. One of the ingresses is ready, so Argo CD should be running. Let me check, and I will share a second. Yet. Okay, so IDP has finished running on our side. And now this is the endpoint, Argo CD, Canoe local test.me. So I'm gonna just share in my browser. I hope you can see my browser. Obviously, the certificates are fake because it's running locally, so they're not signed certificates. But we have an Argo running, okay? So now you might ask, okay, how do I get the password for this thing? Well, don't worry. If I head back to the terminal, I hope this is the terminal, I can do EDP builder secrets. Here you can use custom domain names. It is extensible. There's a YAML file. I'll talk about that later, where you can configure how the package is going to be installed. Actually, this is a base package, but we can specify what packages we want to install and how to configure them. That is totally configurable. So if I do IDP get secrets, my bad, sorry, get secrets, it's gonna show me some secrets. Obviously you need to change them later, but I'm gonna get the Argo one. Yeah, so it's admin password. Yeah, so you can see we already have a fully functional Argo CD for CI/CD that has been deployed, and it has itself deployed the rest of the stack, a GT and an Nginx controller, which is the one we're using to access all of this. So what else are we gonna need? So let's check the code. We have GT admin, for example. Actually, I can see GT, if I'm not wrong, without without needing the admin password, but just to show you. GT Canoe local test, blah blah blah. Okay, same idea, is a subsigned certificate, but we have a repo, and the best thing is, like, the config that has been deployed is already here. So you can see that the Nginx configuration is here. Andreas, don't you worry, you will see this is not big enough. You will see a real platform in a second. I promise. So yeah, here's we have the Nginx configuration we have deployed and so on. And this is just the base platform. So you will see in a second a full-fledged platform running on your local instance. I just want everyone to understand what has happened here before, just for you to know. So no, actually, we don't have backstage yet. So I'll show you this later. Again, the idea is we have deployed a full-fledged platform, not a full-fledged, but a small version of the platform, just by doing this. Simple. It's running locally. It's running in an embedded cluster. Now, let's go for something funnier, right? Something more interesting. So we're gonna get rid of this. Give me a second. Yeah, we're gonna get rid of this platform. We're gonna basically clean up by deleting, and it's gonna be as simple as this: IDP builder delete, and this is gonna clean the overall setup we have. So let's give it a couple of seconds, and it's gonna be gone, basically. So I'm gonna give you a couple of seconds as well to be able to do that. So with that in mind, yeah, let's move to the next part, which is deploying actual packages. But before deploying packages, I want you to understand how these packages are defined. So I'm gonna head back to the repository from Canoe, which is stacks. I'm gonna share it here if you want to check it. And here we have all the deployments, all the deployment types, all the scenarios you can emulate with these packages. We're gonna deploy first this reference implementation. This reference implementation comes with Argo workflows, backstage, external secrets, Keycloak for IAM, all of this is here. So, for example, here's the deployment for, is actually an Argo application, because as you saw before, everything is deployed with Argo. So it's gonna deploy a Keycloak, it's gonna deploy backstage itself. You can see it's gonna deploy all of these things. And then for each of those, we have the manifests inside, like what is going to be needed, the roles, everything. So each of these directories in the reference, in the stacks repository is holding different scenarios of the platform. We can deploy, for example, Terraform integrations. We can deploy Ray operator integrations, local stack to emulate the AWS API. So you can emulate different scenarios for your local platform or build the ones you want. That's the thing. You can refer for packages in a remote registry or in a remote repo, or just have a local directory and make this work. And we will see both options. So let's head back to the terminal. Let's first verify that, that we don't have anything yet. There's no cluster. Beautiful. So now we're going to do the following. If you're following the order, in step 5, we're going to deploy the IDP builder again with the ref implementation from the repo I've just mentioned. You can see it there. It's stacks -- ref implementation. And this little flag use path routing is just to what they recommend. Rather than having multiple domain names, sorry, ingress names, it's same ingress name / name of the tool. It's just for efficiency. So I'm gonna hit this one. This one, just for you to know, even though it's gonna finish creating stuff, it will take a little bit more time right after the IDP builder finishes, because there are a lot of templates to synchronize. This is gonna create a bigger platform, just for you to understand. Okay, let's see if the cluster is already in place. Get pods. So you can already see a great deal of things that are being provisioned. Argo CD again, GT, Nginx, but now we have a core DNS if we want to do, I mean, the ref implementation would work with core DNS in AWS if you want to deploy it. Yeah, what else do we have? You will see more stuff as we progress. Again, it takes some time because there are a lot of manifests to pull and stuff to create, but we need to be a little bit, patient here. But when IDP Builder finish running on the top window, we can already go to Argo CD and see what it's pulling, and and check on the CI/CD. Check on the IDP secrets, logging into the different parts. We will do something similar to what we did before. Okay. So give me a second. Let's see how the provisioning is going. Slowly but surely. It's also deploying an Apache Spark operator in case you want to run Spark jobs. This is part of it. Okay, what else? You will soon see also Keycloak for IAM identity and access management, Backstage, and the rest of pieces. External secret operator will also appear in a couple of minutes. I wish I could make this thing faster, but I think it's, if I pre-do it, it is not as fun. I guess it's interesting seeing how it happens. You can see, okay, so it has finished. Again, as I said, there are still components that are not there, and we're gonna see this. I'm gonna open Argo CD again. Argo CD. Remember that we need to get the password again, because this is a new fresh installation and the password might have been different. Actually, you can get passwords for all the things or just for one component. Here is like Argo CD, blah, blah. So this is a password and it's going to be admin. Same idea. We are using a fake certificate, so it's expected. So I'm going to log in, admin, password, blah, 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 sign in. As you can see, there are some things that are still not healthy. We have way more applications than before because now this platform has more components, but it's exactly the same idea as before. So Argo CD, Backstage templating, external secrets is here to connect to, external secret providers like Vault, AWS Secret Manager, etc. Keycloak is being provisioned, metric server, Nginx. We just need to be patient. Again, there are a lot of different components being deployed locally, so it takes a little bit. But yeah, let's see if I can open again the terminal. Yeah. How is it going? Okay, we already see Keycloak here. Should be healthy. What are we missing? Probably Backstage. Let's refresh. I mean, if you're not used to Argo CD, it's pretty useful also to see your deployments, because you can just go here, see all the components that have been deployed and everything. Again, this is not from the IDP. Argo CD is a well-known open source project, but yeah, just for you to know. Okay, let's wait a little bit more. It's trying hard. It's yeah, some pieces are missing. Let's give it some more time. Argo CD is the best. Yeah, it's cool. It's really cool. Keycloak. Maybe in the meantime we can see GT just to remember that now we're using path routing. So now you route into the applications using slash. So we can do GT. Now we should have more stuff here. You can see here we have the different manifests for everything, the external secrets, IDP builder, backstage manifest, our workflows, all the little things that have been deployed have been committed here. Can it be plugged in Minikube? I have not tried it. Probably, but the thing is I know there are some parameters you can configure with when you use the IDP builder command with some flags, and I'm not fully sure. I would recommend checking their docs. I haven't tried it yet. So, okay, let's be patient. Let's see. Where is backstage? Not there yet. Maybe we can force the sync. Okay, backstage is almost there. Let's be patient a little bit more. And Argo workflows, it's almost there as well. Keycloak. Actually, Keycloak is available as well if you want to. I mean, you have a full-fledged identity access management tool deployed if you want to see it. So I can also get IDP builder, get secrets. Now you're gonna have more secrets because you have more tools. But if I'm not wrong, we should be able to log in into Keycloak as well, and just to see the users we have and everything. Keycloak. No. No. Give me a second. 8443. Yeah. So Keycloak is here. So in theory, we can log into Keycloak, admin password. What is the email? That's a very good question. Maybe Keycloak config. Yeah, the admin password is this one for sure. And I don't remember. I think it's Keycloak. Okay, my video froze again. I don't know why. I think it's. Oh. Nope. Admin. That's what happens. I don't remember which one it is. I just want to show you the management of this thing. Okay, backstage is up. This is the important thing. So let's go to the fun part. So I'm gonna access backstage now, and it's gonna look pretty similar to the one I showed you before, which is the one we use in my company, backstage. And we have federated access already with Keycloak. And you might wonder, okay, what user should I use here? So if I'm not wrong, we need to use the password from user password from the secrets you got before. User password, you see it there. So I'm gonna sign in. This is gonna open a new window. I'm not sure if you can see this window because it's a pop-up, but anyway, I'll just introduce the password, and the username should be user1, if I'm not wrong. And boom, I'm in. This is my my developer portal. Right now there are 0 components. No surprise, because it is that we have not deployed anything, no documentation, no APIs, no nothing. It looks, again, similar to the one I showed you before, but ours is customized. So what I'm going to do, I'm going to create a component. Why not? So let's start with this one, basic deployment, which is going to do a Kubernetes deployment in our cluster. And it's going to create also the code and put it in GitLab. Not GitLab, sorry. Git. So just before doing it, just for you to know what is going to happen here, Backstage is going to create a Git repo with the code for this thing using templates. It's also going to create an Argo CD application pointing to this repo. And Argo CD in a GitOps manner is going to pull this repo and deploy it. And everything is going to be persisted in code, the same way it was done for the other packages and the other components. So let's go for this thing. We're going to create a basic deployment. I'm going to call it PlatformCon. And there's not much that I can configure, sorry. So I'm going to create it. It's generating the component. It's pushing into a repository. Taking a little bit. It's creating an Argo CD app, and it has registered it in our catalog. So look at this thing. We already have it in our catalog with some relations. The repo is here. We can see the pods because it has already deployed a pod in Kubernetes. There's no API documentation because it's a very, very basic thingy. Some dummy documentation. You will see now this doc in the repo, but I think you get the idea. So I'm gonna open the source code, and in a second I will go over the chat. Can we create custom templates as per organization need and make it available in Canoe? And if yes, what tool can help us to create templates? So you can do so, and I'll show you how the manifests are. And there's a tool, which is the template CLI, if I'm not wrong, Canoe CLI. I need to check it to help you with templating. We can go over it later, since you're asking. But I'll show you how the templates are here. Do you version the templates? Depends on what tool you use, actually. Let's check this one. So PlatformCon repo has been created here. I'll go over the template in a second. Well, catalog info has been auto-generated, which is all the information for this thing to be displayed in the developer portal. We have documentation, which is the docs that are being shown there. And here are the manifests, which this is the Kubernetes deployment we have deployed. And actually, so that you know I'm not lying, let's see where this thing is. This thing is in, where did I create this thing? Backstage, GT. Where is this thing deployed? Default, PlatformCon, you see it here. It has actually deployed already a component. Now, how has this thing been generated? You might be asking, and in relation to templates? Well, if we go to, and please, I need to get it right. IDP builder, give me a second. I want to get the right one. Template entities. I think this is the one. Exactly. Here is what the templates are defined. So here is the, I think basic. This is the one we have created. Here you define the template using the scaffolder from Backstage. This is a plugin you have, and you can use the tool I mentioned before. And you tell where to fetch the, where to fetch the templates from, what parameters you can use. This one is super stupid. It's just using, input name, which we'll use for deployment. And as far as I know, I don't see versions here. That's a good question. Not sure why. So within the skeleton, this is what is going to be used as a base for bootstrapping your new component. So you have documentation, the catalog info, and the manifest. And the manifest looks basically like what you saw before, but you have here interpolations that will, substitute this thing with the name we inputted into the Backstage application. So again, just recapping what we did. We created a component in Backstage, which in turn created the repo and the Argo CD application. the Argo CD application was deployed, and this is how we got an application which is running in our infrastructure and completely tracked here. And all of that is running locally, right? How powerful is this thing? In the case you're running a real full-fledged platform, you would have to replicate all of this on your side. Okay, let me check the chat. Can we set it to work with a private external code server? Yes, 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 yes. So one of the things you can do is when you select a package, when you select your packages, you can switch on and off different parts. That is on Canoe documentation. I can find it exactly. Give me a second just to show you. Let me quickly. I know we can remove basically from the, like if you remove one of those packages like Git, then you can either connect it to an existing GitLab or whatever you want to deploy, because you can define your own packages. It's really extensible. So up to this point, I hope you have understood like what we have done here, because now we're gonna go up one notch, right? It's cool to deploy something locally, right? But maybe it makes more sense to do it. Can I use existing EKS cluster in Argo CD? Yes, and that is what the reference architecture is for, as we will comment in a second. Think about EDP Builder, about more local, fast templating, cheap way of the developing your platform, or also doing it in your CI/CD, and the reference architecture as a way to deploy this in a more production-like environment, like in EKS. Keep that in mind. So with this in mind, what I'm gonna do now is I'm gonna head back to the terminal if I didn't close it, and without destroying what we already have, we're gonna, let me see, I'm gonna clone the stacks repository. I'm gonna share it again in the chat. Clone it here. What did I do? No, sorry, I need to use the SSH version. My bad. Git clone. Yeah, share it. So this is also in the reference documentation I share. So why am I gonna clone this thing? Well, I'm gonna show you how to run this thing with packages from GitHub and local packages. And I'm doing so because we're gonna modify slightly one file of one of the packages. You will understand why in a second. So give me a second. So we have multiple stacks here. Now we're gonna use the one which is called give me a second, cross-plane integrations, if I'm not wrong. Yes. And this one has a thing which is cross-plane providers. And here we have provider secret. So this file will generate a secret with our AWS keys to provision whatever, in this case, an S3 bucket, like to provision whatever you need. So if you plug in here an access key and a secret access key that has enough permissions to create buckets, this will work. Again, you don't need to do this locally. I'll update the documentation so that you can try after this session, but I'm gonna do it just to show you. And if we have time, I'll do it quickly also with local stack. We could use Terraform with Canoe, right? You can use either Terraform or Crossplane. I'm gonna use Crossplane this time, but there's also within these stacks, there's one with the Terraform integration. You can also try this one, Giancarlo. That actually is open tofu. I really recommend going over this and testing different configurations. It's really cool. So heading back to the terminal one more time. So now I'm gonna copy directly what I did before, but I need to remember where I placed the repo. Well, actually, I'm gonna edit my credentials somewhere. Give me a second. I need to remember where I placed this. No. Stacks, no. No. Okay. Stacks. Okay. Perfect. So let me verify that I have, this is bugs. No, where are you? Where are you? Cross-plane integrations, cross-plane provider, no. Cross-plane, okay. Cross-plane providers, exactly. Cross-plane providers slash provider, blah, 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 provider secret. I'm gonna open it in my code editor. Okay, yes, I said it correctly. So again, if you want to do this, you will need to set your access keys and secret keys. So with this in mind, I am in the right folder and I'm gonna do EDP builder create. Let's analyze what I'm doing here. I'm not deleting, by the way, what we have already. I am using path routing again. I'm using the ref implementation, and additionally, I'm adding one more package, which is a cross-plane integration. We're gonna hit enter, and this thing obviously will create more stuff. It has to add the cross-plane, provider and all the machinery and all the CRDs this thing is gonna need. So okay, second. Running. In the meantime, maybe we can jump to Argo to see if it's pulling crossplane. You can see it's installing it. Same idea. Crossplane config will be in the repo, in Git. Crossplane should be somewhere. Crossplane providers. So it's here, as you can see. So waiting one more time. Seems the crossplane is around. Still this, still installing this application. Need to wait a little bit more. Now, but just to tell you what we're gonna do now, we're gonna go to create a new repo, a new component, sorry. And this time we're gonna create an application which is gonna request an S3 bucket. And this S3 bucket will be created in AWS from our local setup using crossplane. It could, as we said, it could also use OpenTOF controller to do the same job. Okay, seems that crossplane is up and running, hopefully. Give me a second. So now, if everything is green, we should be able to create a little bucket. Let's do one thing before. Maybe we can also check what we're gonna create. So back again to the backstage templates. This app with bucket, which is the one we're gonna create, same idea, has a skeleton, and it's gonna have kind of customization. Nope, my bad. This is the app service. I need to find where this thing has the definition box. Could it be here? Customization. No. Anyway, I'll find it later. Let's go for the interesting part. So I need to create and go up with AWS resources. I'm gonna create, PlatformCon S3, for example. PlatformCon S3. Yep. I can add labels to my bucket actually. So let's say, yeah, test true. This will be translated to next. Okay, now we're gonna create a bucket configuration options, blah, 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 blah. Deletion policy, delete. Region, we're gonna use central one. We're gonna use the default provider name, and let's add tags for the bucket here. Yeah, mine, or I don't know. Owner is Gail, for example. So this thing is gonna create, or is gonna try to create at least, an S3 bucket. Okay, through the cross-plane integration in AWS. And we will see if it works. Maybe it doesn't work. Okay, so Same as before, it's going to create a repo. This is going to create an Argo CD application as well that is going to pull. And from there, the whole magic is going to happen. So I'm going to open in catalog. We can view the source code is already here. And let me do one thing. So we should see a new application. How did I call this thing? PlatformCon S3. Okay, so it has provided the application side in Kubernetes, and using this CRD, this bucket for crossplane, it has created a bucket, or at least it has tried to create a bucket. And it's telling me that the bucket is available, and in theory, this thing should be created. Let's check on AWS. Give me a second, just to see if our bucket is there. Second. Okay, and let's see if I can show you this. Can I? I hope so. Yeah. Do you see my AWS console? Hope so. Can you confirm, please? Okay, so here's the bucket. The tags are here, Canoe, and so on. And you can see how from a local emulated platform, we can even test infrastructure provisioning plus application provisioning. Answering to the question, the difference between the labels added at the beginning are, the first ones are labels in Kubernetes, if I'm not wrong, and the second ones are tags for the bucket, but we can verify. We can go to this app. We can go to the deployment. We can see the code. Labels, where the heck are them? If they're not here, maybe they are labels on the, let me see, on the backstage part. Why don't I see them? Not sure. They should be there. Give me a second. Maybe there are labels on the application itself. Manifest. Well, not sure where they are, to be honest. Is there any build observability functionality in Canoe? Not that I know on the reference implementation. I guess they will always default to open source stacks, as the whole stack is open source. But in the end, since you're mostly deploying this target architecture to Kubernetes, EKS, there's already a widespread set of tooling, like the whole ELK stack, or stuff like that, or private vendors. But as far as I know, in the reference architecture, I don't see anything about the specific observability, as far as I know. Okay, so yeah, what I'm gonna do finally is I'm gonna delete the app, and this should also get rid of the bucket. So PlatformCon S3, let's say goodbye to this one, delete. Yeah. Okay, bye-bye. And if I'm not wrong, the bucket should be gone soon. Exactly, no more bucket. As simple as that, and all from a locally deployed platform. So there's one, I don't know if we have time, there's one more thing I can show you if you wanna quickly test it, which is if you don't want to use this in AWS, you can always just swap crossplane back by local stack. Just to show you, we're gonna do this real quick. Same idea as we did before. It's also in the documentation. So now we're gonna deploy the ref implementation plus local stack integration. This is probably not gonna delete crossplane because it's on the repo, but for what we're gonna test, it's fine. So this will basically create another provider with local stack. If you don't know about local stack, it's just a container which mocks AWS API. So yeah. Give me a second. Okay. So let's see if it deploys. But yeah, it's just for you to know that you don't need to use Amazon for this. Let's see. We should see also a new app for local stack coming in. Cross-plane provider, local stack. Here you are. So we should be okay. So now, basically, if this thing goes up and running, we should be able to do exactly what we did before, but with a fake bucket. But you can verify that your integration works. In theory, this provider is here. Yeah, I don't know why IDP Builder is still waiting for something. Maybe we have some issue with the pods. Local stack. Where is local stack? Yeah, local stack is up. I think we should be good to create this thing. Not sure why it's taking longer. Anyway, so what we can do finally, just to close this, is we can, same idea as we did before. Yeah, PlatformCon, local stack. By the way, since you asked before, here it says labels to apply to the application. You're saying, Giancarlo, you have a lot of Terraform modules for deployers, 3 AM security groups. Could I load these modules in Canoe? You can reference them with the OpenTofu provider. We can give it a look quickly. So give me a sec, blah, blah, blah. The only difference from what we did before is that here, the region doesn't work. I just need to, for a provider, I need to specify here local stack, because I'm going to use a specific provider. This is what we're going to deploy. Yeah, and I'm going to create it. So let's give it some time. The new application should be somewhere in here, maybe. Local stack. It has created a bucket, and the bucket is available. Even though you see here S3 bucket, obviously this is fake. It is mocked by local stack API, but can be used to verify quickly and locally. So before jumping to the last topics, since Giancarlo mentioned this thing, you can, on the stacks with Terraform integrations, use the OpenTofu controller. So basically, this TOFU controller is the one that you can use to reference existing modules from your repositories. And what you would do is give inputs to these modules through Backstage, like inputs of the templates, and these templates then will be translated to the CRDs of the TOFU controller, and this will actually bootstrap the application. Feel free to give it a look. Okay, so with that in mind, we don't have much time. I just want to show you quickly one more thing that we can do, which is in code spaces. If you want to give it a try, I'm not going to do it to the full extent, but just want to try it. Code spaces, I can, yeah, I have already code space created, but you can create your own code space. The guide is linked in the documentation. It is fairly simple. What you need to do is just copy and paste, but also if you don't want to run this thing locally, you can do it in your code spaces. Just to work. It takes a little bit. Yeah. So what will you do here? You will, give me a second. Get the latest release of the IDP builder. I'm not doing anything really different to what we did locally. I'm just getting the CLI, I can do IDP builder version. Some idea. Yep. And I can, we're gonna use the name, blah, 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 create. Yeah. So we can use the IDP builder. Here, actually, you're gonna see advanced options of the IDP builder. For example, here you can change the host name and the ports, because otherwise it wouldn't work. So the same thing, you can do it locally. So I'm just gonna create it. Same idea. Ah, wait, my bad. I forgot to clone the, sorry. I need to first clone the stacks repo. Give me a second. Git clone stack, blah, blah. Oh no, I already have it here. Haha, my bad. I cloned it yesterday. So yeah, one more IDP builder, create, blah, blah, blah. And the same way we did before, this one is gonna generate a version of the IDP builder. It's quite a lot of CPU for code spaces, but it works. So it might take just a little bit more, but it's exactly the same idea as we did locally. If you don't want to do it locally, you can do it here. So yeah. In the meantime, while this thing is coming up, I just want to walk you finally through the reference implementation architecture. So give me a second. Oh, it says the application is already available. Not sure if we can see it. Again, yeah. Let's see. I think we need to do something like /Argo CD. No, probably it's not yet up. No. Anyway, I'll walk you first through the reference implementation. If I find it somehow, did I forget? Yeah. So the reference implementation on AWS, and this is the one for EKS, it's here. As I mentioned, this current version of the reference implementation is no longer maintained. They're moving to a new version, but I encourage you to give this one a go because it's prepared to deploy this. Let me increase the size of this thing. This full-fledged platform, very similar to what we have just done, but ready to deploy in EKS with external DNS, with Cert Manager and the whole thing, which, to be honest, is pretty similar to what we do today. This thing is gonna need Terraform, it's gonna need access to GitHub organizations and a lot of things. So it's worth giving a try if you want to see how this thing works for AWS and deploying on EKS. But as I say, this thing is probably getting a better version soon. As you can see, there's actually a open issue here. Open merge was actually where they are. No, an open issue where they are tracking this new version. So, just keep that in mind. But yeah, it can be deployed to EKS using this one. I'm gonna share the link here as well so that you can see it. And finally, let's see if this thing is deployed or not. Yeah, this one is the one in code spaces. As you can see, it has a terribly awful host name, but it works. Same as before, once the terminal finishes running, I can get the secrets. I'm not sure how long is it going to take. But I think it's clear for you, right, that you can emulate basically all that we have just done, even in code spaces. So pretty powerful, having a full-fledged platform, compressed into small space, to say so. Well, while this thing finishes, because I don't want to take longer, I'm just gonna finish and sum up. So yeah, I think we've done everything that we have here. We deployed IDP Builder, deployed basic platform, full platform, deploy components and infra, test it in code spaces, and review the reference implementation. So finally, the conclusions. I guess this is already taking long. So let's jump to it. So, platform engineering as a discipline makes a lot of sense, and it has paid off for us big time. It brings efficiency and scalability, from the very beginning, autonomy for developers that can work in a self-service manner, improves developer experience, and also provides standardization by using templating, guardrails, and so on. Building a platform from scratch I can tell you from my experience that it's complex, it requires a lot of trial and error, and maturity for your platform takes time. It takes time to get this thing right. 5 years ago, Canoe did not exist, so we did it by trial and error. Now that Canoe is in place, you can use IDP Builder for test and validation, for developing new features, iterating fast and cheap without the need of, having a full-fledged platform. You can just bring it up on your CI or locally. You can iterate faster than by having full-fledged environments. And it gives you a quite integrated platform. You've seen it here. I just run a couple of commands and the whole thing is there. So it's really useful. And it's extensible. You can customize it with your own packages, and you can use your reference, the reference architecture to use it on AWS, for example. So these are my conclusions so far. Before dropping us one, I want to see, this thing finally finished. So just in time, we can get the secrets for Argo, as we did before. Admin, password, sign in. And there you go. It's still provisioning, but it's the same stack as we saw locally. So you can also practice in code spaces. Everything is in the documentation. I think this is clear. So again, I think the conclusions are clear. So if you have any other questions, now is the time. We have 5 more minutes. Otherwise, if you have anything you want to check, feel free to add me on LinkedIn, drop a message. I'll be happy to guide you through this. And thank you everyone for joining. I really encourage you to, check the reference implementation, check the different stack options with packages, try it locally, play with it. It's really cool.